Welcome to Tom's Aviation. I hope you enjoy the next video and subscribe.
Airtaxi, built to address one of the biggest challenges for urban areas. Congestion, traffic. How many of you have been stuck in traffic in a big city, missed a meeting, maybe a flight, a good portion of your sanity? We've all been there. So imagine going into a LaGuardia or JFK, getting off your flight, taking your phone out and booking a trip on this gorgeous aircraft. 20-minute flight down to city center, Manhattan. It's quick, it's easy, it's efficient, it's quiet, it's clean, and perhaps most importantly, what a brilliant way to get around. So that's the idea of what you're looking at right here. You'll see there in the back, we're going to get there, but I'm just going to tackle it. So this aircraft has 9 batteries powering 18 motors. And there's a few things important about that. One is redundancy. We got the ability to lose a battery, heaven forbid, and we don't plan on it, or lose a motor, even several motors, and still maintain flight integrity. The other thing that's important about this is we've completely circumnavigated the idea of charge time. It doesn't matter. We're going to do an automated full robotic swap in about 60 seconds when this thing hits the ground. And so, very high efficiency. Perhaps more importantly in this case is we are putting in a thermo-cooled battery, fully charged. So we're mitigating one of the biggest concerns around electric power, which is heat. And that's just one of a number of things that you'll find that's pretty remarkable about this aircraft, and just simple. Another example I'll give you, I mentioned the 18 motors. You'll notice that they're all in a fixed position. Excuse me, varying angles, even some are a little bit higher than others. Why is that important? Well, the only moving parts on this entire aircraft are the bearings. Think about that in terms of cost of production, safety, maintenance. Fewer moving parts equals less risk. And so this is, again, a really simple, well-thought-out design. And the configuration of the motors, their elevation, some counter-rotate, we still can maneuver this aircraft in any way that we need to and have optimal stability. So some pretty remarkable engineering. A few other priorities for us, in addition to safety, of course, were quiet, clean, and, believe it or not, affordable. So let's talk quiet. The sound profile of this really is a function of the more motors actually comes down, makes it quieter. So about 300 feet, you'll barely even be able to hear this aircraft against typical city noise. It's very quiet, clean. Of course, we're 100% electric, 0 emissions, and that's a huge priority for an urban setting, which is where we see this being an enormous asset and answer to some challenges. Talk tech for a minute. This entire aircraft is about 1,500 pounds. So remarkably light for its size. Predominantly carbon fiber materials. It's engineered, designed, and built in Germany. In fact, most of our team here today is from Germany. It's got about a 440-pound payload. So the idea is a couple people, some luggage, and you're good to go. About a 22-mile range, 35-minute flight time. And again, when you consider that over 90% of the major cities across the globe, the airport is within 15 to 20 miles from the city center. So that's really what we're talking about. Airport to city center to potentially several venues around the city, and we get there quickly, efficiently, and safely. Now, our goal, what you're looking at here, is the latest iteration. This would be a fully autonomous air taxi. Think about that for a second. Autonomous air taxi, no pilot. I just book my trip, tell it where I'm going to go, and I go there safely. Now, the initial iteration of this will likely be a piloted version of that. How many of you saw our test flight on Tuesday? Anybody? Oh, a few of you. Nice. The rest of you should be ashamed of yourselves. I'm just kidding. Go look at it. It's remarkable. It was actually the first manned eVTOL, electric vertical takeoff and landing flight in the United States. I will say this, however, it wasn't ours. Our first one, which was the first ever in the world, was in 2011, believe it or not, in Germany. Since then, we've got over 1,000 flights. And we've had 7, including this week, 7 very public demonstrations or test flights that have been manned, unmanned, and fully autonomous. So we're there technologically, but we've got a few things we need to figure out from a certification perspective. So that's really the ultimate question. Regardless of how beautiful it is, well designed it is, viable it is, if we can't get it certified, we've got a beautiful paperweight. So, as of 2019, we're working with the European Union Aviation Safety Agency, which actually has the highest standards in the world. And with them, we set up a new type certification, new classification of aircraft, eVolocable. Since that time, Volocopter has established both a design as well as a production approval. No other eVTOL company in the world has either one of those, much less both of them. So we're on track for a formal, bona fide, legitimate certification, and that's about 2 years away. 2-3 years is all we're looking at to have this commercially available and viable. A couple city partners in tow. We've got Singapore, which would be likely the first spot, and then secondarily Paris, believe it or not. They have this little thing called the Olympic Games in 2024, and pretty excited about the idea of delivering this kind of urban air mobility to the games in 2024. So.